So I thought it was important to start with the central feature of this curriculum. That is, of course, passion. I hope you will see today how important passion is to this curriculum. It's the passion of the instructors and the students that really make passion-driven statistics successful. In passion-driven statistics, we approach statistics in the service of our students' research and in the service of their passions. We do not teach statistics as a standalone form of mathematical computation, as is often the practice in introductory statistics courses. Instead, we strive to serve students with the necessary skills of approaching a scientific problem from a statistical perspective. Our curriculum is modeled around this principle, that statistics is always in the service of your research. And our hook is that statistics can also be used in the service of your passion. I think some context is important to start with here too. On the one hand, statistical analysis is arguably the most outstanding point of intersection among diverse disciplines. Yet developing analytical skills is often viewed as an obstacle rather than an opportunity to pursue our own interests and to answer questions that you feel passionately about. How many of our students dread statistics in whole or in part because of some sort of math anxiety or past negative experiences with math? Well, this is why passion-driven statistics was created. Passion-driven statistics offers a welcoming and empowering space to support introductory statistics students in conducting original research, asking original questions, and communicating methods and results using the language of statistics. Here are some of the nitty-gritty details of the curriculum. Passion-driven statistics is a 3-time NSF-sponsored curriculum that specifically engages students in data-oriented projects. We are currently working with the 3rd and final grant from NSF. The goal of this final grant is to disseminate the curriculum to partner institutions across the country, maybe such as you listening here today. Passion-driven statistics is an ongoing initiative for reframing introductory statistics experiences in order to tackle real-world questions across multiple disciplines. From existing data, students pose questions of interest and then use statistical software to turn raw data into useful information. Passion-driven statistics uses a flipped classroom approach. The course and related experiences are designed around student research projects of their own choosing, and we offer individualized, hands-on experience in one of many statistical software platforms. And finally, the course is built around 6 recommendations from the American Statistical Association. These are the guidelines for assessment and instruction in statistics education. This is an incredibly informative framework, and I certainly encourage you to check it out. Let's shift gears now into the more practical nuts and bolts of the curriculum, the pedagogical approach. The basic approach for this curriculum is centered around the students. They set the topics by selecting questions they feel most passionately about, make the decisions about how to answer those questions, and do the work to craft what we call their story. There is no sage on the stage in this course, as it is almost fully flipped. We've moved the lecture clips, which are actually video lectures, outside of the classroom, and students watch them before coming to class to gain a conceptual understanding of what we're doing in class. These are short and high-quality videos that are provided free for your use. Class time then is spent working on lab assignments that directly relate to the video lectures. Because of this, there is an expectation that one-on-one support will be needed by students, and we do provide lots of it since we don't have to lecture in class. Our class is very active and very engaging. I should note that this is the all-in curriculum. In my course, the 15-week course, here's what we do. Weeks 1 through 3, I call, "What do you care about? Let's study it." During these weeks, students review codebooks for available data. They select 2 to 3 research questions and generate a few testable hypotheses, and they go to the literature to learn what has been done with their topics and sometimes write a research plan. In weeks 4 through 5, I call, "It's all about that SAS programming," because I use SAS as my software program in my course. Here, students get a deep introduction to the statistical software basics being used in that course, whatever that might be for you. We also spend a lot of time formatting and managing data in the service of a research question here. So for example, coding missing data, collapsing variables, aggregating variables, etc. Week 6 through 8 is reading the story of our data. This is the first week that starts to look more like a statistics course than a research course. Students learn about their individual variables through conducting a variety of univariate analyses here. They also take a first step toward bivariate and multivariate analyses by graphing their predicted relationships among their variables and learning to interpret those graphs. We then move into weeks 9 through 12, which is how do we find the answers? Excitedly here, students get to answer the research questions through inferential statistics. Students do both bivariate analyses, for example, ANOVA, chi-square correlation, and multivariate analyses. So for example, moderation, identifying confounding variables, and multiple and logistic regression. Last, weeks 13 through 15 is show and tell. We're then able, at this point, to help students fully answer their research questions. A fair amount of time is saved at the end of the course for completing the research project, which is usually in the form of a research poster and most often a campus or class presentation. This is my favorite part of the course by far. Two central features of this course are that we provide students with real and rich data sets that stimulate curiosity, and from this, students develop their own research questions. The content of the course is then delivered and presented completely in the service of those research questions. Our data comes from three main sources: public access sources, so these are the major data archives; community engagement, so for example, a partnership with a local school district or a private social service agency; and faculty data sets related to faculty research. Our curriculum is also inclusive with technology, but all of our partners include technology in their courses. So you have the flexibility to use whatever statistical software program you would like with Passion-Driven Statistics. I use SAS and would highly recommend it. We do support almost all statistical software programs, and we have translation syntax and student-focused lecture videos for SPSS, Stata, SAS, R, and Python. Next, our Passion-Driven Statistics website is a really good place to start if you just want to check out the program. So the web address for that is passiondrivenstatistics.com. The website has our videos, the ebook, publications both describing the curriculum and reporting on its efficacy, there are a lot of them, and much more.